Okay, hi everyone. Welcome back to day 2 of the Nextflow and NF Core training. Today we will just kick off pretty quickly. Oops, sorry, it's getting a bit of feedback here.
Chris, you're muted if you're talking.
Yeah, sorry about that. Just fixing all the feedback issues I'm getting with noise. Yes, hello everyone. Sorry about that again. So we're just going to jump straight back in. Yes, okay, so we're straight back into it with day 2. Today's session will be another big one, so we do have a lot of content to get through really quickly. What I wanted to start with is a special thank you to James, who's already corrected me once today for being on mute, as well as he's going to be answering a lot of questions happening today in the background on Slack. So a special thank you to him. Also Marcel, who's going to be sticking around a little bit this morning, and he might take off around half time, just because it's quite late for him over in Brazil. Anyway, so today we're just going to jump straight back into the training material. So you remember this from yesterday, which is just the training material that you can access through the Sakura training.sakura.io. Obviously at the top there's a table of contents, and what you remember is that we access this content through Gitpod, or most of us did. So here we have different options about how we can sort of revive this training material from yesterday. The first is that you can actually go to gitpod.io and go to this dashboard. So this will be hooked up through your GitHub account, and you'll be able to sort of find these sessions that you brought up previously. And this is one of the really cool things about Gitpod, is that you can actually go back and sort of come back to things that you've done previously. So you can see here, this was what I was doing yesterday. It's given this arbitrary name, there's 30 changes. So that was all the material I was playing with yesterday. So this is relative to the initial sort of base repo. This is what I was playing around with last night, which was just 4 changes. I was just testing out a few little bits of code. But what I'm going to do today, just for proof of concept, is that we're just going to start a new session like this. So again, it's just going to spin up a new sort of working environment for me, opening a new workspace. And as you can see here, we've got this brand new environment, exactly the same as what we started off with yesterday. We've got all our files down the side here again, which we can open and close with this. We've got this here as a simple browser format. It's just going to ask me, do I want to do some pull requests, which is no. So here's this material here. I'm just going to close this because I've already got it sitting up here, but you're more than welcome to keep that open as well. So before we sort of start on today's content, I just want to sort of summarize some of the things that we talked about yesterday, and sort of just touch on Docker and containerizing again, just because I skimmed over that really, really quickly yesterday, and I don't think I did it justice, sort of making sure that I can communicate the importance of Docker and how you can make these really nice images, which can be used in Nextflow. So thinking about script 7 is kind of where we got up to yesterday. We're just going to sort of go through and sort of talk about some of those words that I used in passing. Some of those words are quite specific to Nextflow, and they're probably quite unfamiliar. So we're just going to work through the script really slowly to make sure that, or at least refamiliarize ourselves with some of these words and concepts that we talked about. And then today we're really going to dig into them in more detail, particularly operators, channels, and processes. So when we think of a pipeline, obviously it's all those steps, and that's something that Evan talked about yesterday, but generally we start with data that's coming into the pipeline. We're going to do some sort of manipulations, and then we're going to have some sort of output. So thinking about this, And also thinking about how this might apply to your own data or something that you might be doing now or in the future. The first thing we do is kind of like just read in or read in the data and sort of set some information that will be relevant for defining sort of outputs from your pipeline. So that's what we're doing up here. We're using this parameters.reads, parameters.transcript file, parameters.multiqc, parameters.outdir. We're just setting these kind of arbitrary strings, which are in fact file paths using this project directory. This is of course where the project directory where you're executing from. All of this is just creating a relative path. We set these at the top so that they can be used sort of throughout the pipeline. What's happening in here is we're using this log info. So log info is just a way of getting a nice printout of some of that information that we've just put into the pipeline. Dot strip indent, this is a little bit sort of groovy-ish, but it's basically saying remove all the white space. And here we've got, we're defining our processes. So processes is one of those keywords that I sort of mentioned already, and will keep coming up as a concept in Nextflow. A process is basically like the part of the code that's actually doing the work. So for us, in these processes, we've got three main inputs, which is the inputs, the outputs, and the scripts. The inputs we've got, we can sort of set these slightly differently. So it could be a path, it could be a value. Here we've set a path as transcriptome. Transcriptome is just like an arbitrary name that we've given it, but we can reference it in the script using this variable down here. The same with output, that we've sort of given it this sort of fixed name, which we reference down here. But because it's not a variable, we're not using the $sign. And we're kind of doing the same thing with this index process. So process, given the name index, everything in those curly brackets is a part of the process. A similar thing here is happening for the qualification process, which everything within these brackets is a part of the process. Again, we see the input, the output, and the script. We see here that we're using this salmon index, which is something that we do define up here, but technically you could call it something different. We'll sort of touch on that a little bit later, but these names are reasonably arbitrary what you actually call them in the inputs and outputs, as long as they're consistent between what you're calling them here and what you're actually calling them in the script as the variables. We sort of talk about a tuple here. Again, we'll come back to a little bit later, but it's basically creating a kind of like a channel, but in that channel there'll be different elements. So for example, here we've got the value as well as paths or the reads. Down here again, fastqc, input, output, script. What I haven't talked about so far again is these tags. So these are directives. Directives are just like little bits of extra information that you can help use to effectively tune your process. So here we've got the salmon on sample ID, so that helps us get that nice little readout next to our command line in the command line when we're executing, as well as we've got like the published directory here as well. Make it a little bit bigger for everyone to see. Multi-UC, another process, I won't go into that. But the interesting thing here is that once you've got all of these processes defined, you can use these things called, you can set a workflow script or the workflow down here, where you can import the data that we talked about using something called a channel factory, which is another concept we'll cover again today. For here we're using from file pairs. So that was the one that created that tuple, which was kind of the base name of the fastq files, as well as two fastq file elements that we talked about yesterday. We're setting this as, we're calling this read pairs channel, and then we can sort of reference that down here in the script. So then just working through the main script, we've got the index, we've got the qualification, we've got the fastqc, which are all those processes that were just defined, as well as multi-QC, where we start to use operators. So operators is something else that we'll be talking about again today, but we're using mix and collect, which are kind of two of probably the more key concepts for sort of channel manipulation. So we're effectively stacking these different channels, and then we're collecting it all together into one item, so we can feed all that into multi-QC at the same time. And then just down here, we've got like a workflow on complete. So that's after everything else is finished. It's got some more log information using a effectively like a Java-y if-else or Groovy-ish if-else statement saying, if it's worked, do this. If it hasn't, do this. So I just want to sort of cover that again very briefly, because there was a huge amount of information we covered yesterday, and we sort of came up with this proof of concept RNA-seq pipeline. But what I really wanted to reinforce was that this is kind of just proof of concept, and it was okay if some of these ideas and words were a little bit hard to sort of follow and understand, because that's what we're going to be covering today. Anyway, just as a reminder, we can sort of execute this again. Nextflow runs script 7. Because this is in the new environment, I haven't actually set, I haven't enabled Docker in my configuration file. So that was something we did yesterday, was we put the, oh no, that's the wrong one. Where are we? Nextflow.config. What you might remember is that yesterday we equals true. So we just added this into the script so that I didn't have to type this in with Docker in every time. So what we should see now is that I can re-execute this without any problems. Yep, no problems. The other thing we talked about very briefly was this idea of the different processes running in parallel with Nextflow. And this is one of the real strengths of Nextflow, is that it can parallelize processes, so it isn't like this sort of linear, everything has to happen at the same time. As a reminder about that, if we change this to a glob, this is going to be including all of the different files we have in the data and the gggal, so this will pick up the gut, the liver, and the lung. We can run this again, but we're going to go with resume, which is another thing we talked about. So of course, resume just looks for the cache, and if anything hasn't changed, could be used from a previous run, it will. So we can see here that 1 of 3 was cached, but because we're now including 2 new files which have been picked up as a part of that glob, there are an extra 2. That process is getting run an extra 2 times, those extra 2 sets of data. So that's just a very quick summary of what we've already covered yesterday. And now today, we're really going to be digging into more detail. So going back to the training material, I've very, very quickly summarized basically everything here as a part of the simple RNA-seq pipeline. One thing I didn't cover yesterday, and I would like to touch on it very quickly again, is that you can actually run pipelines straight from GitHub. And this is something that's really common if you're running an NF core pipeline, for example. So here, for example, Nextflow IO is actually a GitHub repository. So if you have your own GitHub repository, you could replace it here with the name of the actual repository there. Doesn't like that. See line 3. Let's try a different revision. So what's happened here is that there's a directory, there's some sort of issue. Okay. So let's quickly let this run, and then I'll scroll back up to look at the code. I should probably do that now. So here what we've done is we've just run Nextflow using a GitHub repository. So this could be sort of any major Git provider. It'll automatically just pull it from GitHub, so you don't have to necessarily download a local version of a pipeline. You can just pull it straight from Git. And this is really popular for collaboration. RNA-seq here is the name of the repo. This is your repo name. So this is the Nextflow IO, and this is the repo for NF, RNA-seq NF, which is just it's basically the same simple pipeline that we've been using, and here we're just using with Docker. But as an example, we could just change this to my GitHub or something similar. I'll spell all that wrong. But if I had a pipeline in there that I was playing around with, you could just execute it like that. What I've also done here is I've used an example of using the version control that you can use with GitHub and Nextflow. So say you had a different revision or a release, and it was called 2.1, you could use that. You could use a branch called it like dev branch, or if you had the main branch or the master branch, or development, feature, basically anything that you've called it in feature, keep spinning around. Anything you call it in Git, you can also use it basically in Nextflow to execute that. So if that's something you are interested in, make sure you go back and check out that training material in more detail. That's sitting in 3.11. Just because we are sort of ripping through the time quite quickly as well, and I haven't even started on today's content. Again, I do encourage you to go back and look at this in more detail, especially if you're not familiar with Docker and how to make Docker images. This is a really nice example of how you can create a simple Docker image and how that can be integrated into Nextflow to make sure that all of your data analysis is completely reproducible. So again, like this example, it's just using like a really simple say hello Docker. You can add in salmon and then use it using the same example that we've already created with RNA-seq. Okay, today's content. All right. So I've already mentioned kind of these concepts today of channels, processes, and operators. Channels kind of being the key data structure in Nextflow, and that's what we're going to start with. And we'll talk about processes. Again, we've talked about these a little bit already with these different parts of the process blocks, the script, the input, the outputs. There are also a couple of others that we'll sort of delve into when directives have already talked about, and as well how to organize these. And then, of course, operators, which are probably the hardest concept to kind of grasp. And it's really for manipulating. Manipulating is a bad word, but it's for helping reshape data to make sure that the channels are made up of the different parts that we want it to be, so that we feed it into a process. Everything is as we expect. Okay, so starting off with channels. What is important to understand is that there are two different types of channels. We've got queue channels and value channels. And we are going to dig into those a little bit straight away. This is quite a nice explanation, but it is still quite hard to grasp. Or I do find it quite hard to grasp sometimes, even after a few years of experience. So a queue channel is an asynchronous unidirectional FIFO queue that connects two processes or operators. So what that means is that asynchronous operations are non-blocking. Unidirectional means that it's from a producer to a consumer, and FIFO means that it's first in, first out. So when we look at this simply, we can jump back to here. So what I am going to do, down the side here, you'll see that there's a snippet NF, which is the first code block that we've talked about with the training, this one here. So we're just going to run that straight away and see what comes out. Nextflow run, snippet.nf. So again, this is when we're sitting in the NF training directory. If you're not in this directory, then you might need to go up or down one, or CD up or down, just to make sure that this is relative. So we get this error message here. Well, it's not really an error message, but it's basically saying that it doesn't like this print line. So print line is very it's a Groovy function, and it doesn't actually like that. And that's just because this is a channel. If we were to change this to, if you call this a straight string, Chris, hello. Then we would change this to print line ch2. What's going on there? Once again. Okay, there we go. So I didn't say that properly the first time. So basically what's happening here is because this is just a straight string, it's a lot easier to print, but if you were to try and do a ch.view, it won't like this much. So this is just like a subtle difference when you're trying to like actually view something in the command line. But when you are using a view, it's a really good way of viewing a channel, which is what we're trying to demonstrate here. So because this is a channel, we're using it as an of, meaning that this is a queue channel. So this is the unidirectional first in, first out type of channel. We've got these different parts of the channel, 1, 2, and 3. You can see that here. So when this is actually getting printed out, it's printing these out as 3 different sort of items because they're 1, 2, and 3, and they're getting treated separately because it's this channel idea. If we were to try and do something like a collect on this, then we would see it a little bit differently, but we'll come to that soon. So value channels, being the other type of channel, are a little bit different. So what we can do here is just use this example again. So we've got channel.value. Value is a different operator. This is in comparison to value.of like we had in just previously. So we can hit to run this again. Then we can just see down here in the command line, hello, hello, hello. So that's for each one of these channel.views, view being an operator. We are printing it out to the terminal. And effectively, you could just keep doing this as many times as you want. So we've done this value once, and we could change this to anything you ask, hello world. Save that. No, there we go. So it's just printed out as many times as you want. I mean, technically, when you do this as an of, you will still get some type of output here, but you'll see that it's stacked a little bit differently. Yeah, so because this isn't in any particular order, this is just suggesting that it's first in, first out, meaning that whatever was interpreted by Nextflow first, or as soon as this information came through and the channel was filled, it just started printing it out. It didn't actually keep the same order. That's something you can do with things like lists, but not necessarily with a channel of. So all of this is quite hard to sort of to follow, and I don't think I've explained it particularly well. But what I want you to take away is that there are different types of channels, depending on how you actually bring it in, I guess. So like here, for example, was the value. Up here, there was of. And it will depend on what type of data you're bringing in. It might be different if it's a path, if you've got a list, if it's a list of paths. There's lots of different combinations of how you might want to actually interpret data. Down here is just a note saying that values can be created using a value factory, but you can also use these other operators to bring some in, and these are basically math operators or other operators that will produce value channels. So that's just that single element that can be reused. A lot of this will make more sense soon, I hope. All right, so again, we're just going to slightly change tack and talk about channel factories. So up until now, it's just been a demonstration that there are different types of channels, and this is now moving on to channel factories, about how channel dot whatever will produce these channels from the information that you're inputting. So I'm just going to copy this again as an example, and we'll just talk about it as we go. So get rid of that, probably don't really need to. So here we're going to produce 3 different channels. We've got channel 1, which is just an empty channel. This is quite a good way of creating what might be a channel that is then filled later in your pipeline. It is quite a common thing to create an empty channel so that you can sort of backfill it later when something is being produced. We've got the channel.value, hello there, and channel.value 1, 2, 3, 4, 5. So this is an example of where you can have effectively a list inside that channel, and that will be treated as a single item or a single element. So again, we're just going to print this to show it. Cool. So what I should actually do here is put on a view. So without this, we're not actually going to see any outputs. Here it's just viewing these channels. So as I said earlier, view can be used to view a channel. If we tried to print these, so if we use something like print line, this wouldn't actually work as well, or wouldn't work at all, because these are channels, not just straight values. If we were just to input this as a straight value, so the hello world without it being a channel, you would be able to see that. Cool. So this is a little bit hung up because this channel is empty. But here we can also see channel2.view being this hello world, and 1, 2, 3, 4, 5 being this channel here. So this is effectively being treated like a list. There are ways to split out a list. There's different channel factories for that, but here, because we've imported it as a single value, it's just included it as one list. Okay, so now we're going to be changing a little bit to a different type of channel factory. So what we're just going to do is work through these different types of channel factories, try to think about how, if you were writing a pipeline, the different situations where you might try and include these different channel factories. So like if you're trying to import your data or some metadata or some type of variable or flag that you want to try and like integrate into your pipeline to sort of manipulate what's happening at the different steps. Kind of tuning a different parameter, for example. So channel of, this is going to be one of the queue channels, of course, different to the value channel. So we've got 1, 3, 5, and 7. We're going to be viewing it. So here is an example of, you can actually add text and kind of a combination of sort of raw string values, as well as the variable that you're actually going to be taking out from that channel. So it, or item, is kind of just like a reserved name for addressing different elements in a channel. So channel.view, it is going to be printing value this item. So let's just print that and see what we're going to get. Okay, so as we might have expected, or as you might have guessed, we've got 1, 3, 5, and 7, and as we print this as using the view operator, we see value it, it being 1, 3, 5, and 7, item 1, 2, 3, and 4 here coming in from this channel of. So this can also, there are a lot of other cool ways you can kind of use channel of to bring in like big long lists of data or different bits of information that you might be interested in. Here, for example, we can use channel of to bring in the numbers 1 to 23. So dot, it's kind of like a groovy way of saying 1 to 23, X and Y. Obviously, this could be something you might use if you were trying to specify all of your chromosomes in the human genome. Yep, and technically you could change this to anything you want. So you could say that, and then I want to add the mitochondria, something like that. Oh, change that back to that, or I might throw an error. Cool. So here, just because I've changed it to 1 to 10, it's only going to print out the numbers 1 to 10. I've added an MT, an X and Y. And it's going to print it out in this order, just because that's how I've specified it here in the channel. Okay. So this is probably one of the more useful channel These next two are probably some of the more useful channel factories, but I think they're definitely worth digging into. So here, if we were to import a list, so the list is described by having these square brackets. We could add hello world, yay. We're going to import this as a list, and we're going to use this channel factory from list, bringing in this list that we've named up top here, and we're going to view it. So we're just going to check out what that does. So here we can see each of these has been brought in, each element of that list has been brought in as a different element item there. So the thing about this as well is that we could make this as big as we want. You could try and include different pieces of information here, depending on what you're trying to do. We don't actually have to have these fixed. These could be something like numbers. You can kind of mix and match these depending on what you're trying to bring in. But what I'm really trying to demonstrate is that if you have a list, you can bring that in. It will be treated a little bit differently to a channel.of being the operator, rather, which is different to from list. But there's lots of different ways to kind of like string these together and do different kind of manipulations. Okay, so from path, and then this is probably the most commonly used, one of the most commonly used channel factories, and this is probably the best way to bring in your data into a pipeline. So previously we've used from file pairs. Here we're just going to be doing from path, which is a single file. You could try and include more files here as a list or something like that, but ultimately, if you want to just bring this in, let's just call it channel, and then we're going to do channel1.view, just because we want to view the contents of that file. This is just bringing in the path to that file, and then the channel basically becomes the path to that channel. So it's not the file itself, but it's the path to that channel. And that might be a little bit confusing initially, but when you think about it, when you're feeding in a path or a file into a pipeline, you want to designate the path to that file, not the file itself. The tool itself and the script will go away and look at that file or bring that file in. What you're effectively doing is just directing it to that file. So here, for example, we've just used the data meta glob everything in CSV, and if we go and look at the metadata here, you can see that we've got these two files here. And if we're only looking at one file, we could change it and just look at it straight like that. So what we can do here as well is there's lots of different options when you're trying to bring in these files. So this is kind of what we touched on yesterday when we used check if exists. So this is what we're doing when we're looking for those files with the from file pairs. So you can definitely add this in. Here's a quick exercise. I'm just going to skim over this quickly because we're quite behind on time already. Here the example is we're looking for hidden files at the same time, which is another example here. So for example, you're looking for hidden files. When true, it includes the hidden files, but by default, it wouldn't look for those. So depending on what kind of file structure you have, and if you're looking for hidden files or not, or trying to use relative paths or checking if exists, you can really tune how files are brought in using from path. Again, just because we're behind, I want to try and get through this quite quickly. But from file pairs, this is the same channel factory that we used yesterday. So what you remember is that we used this data, the chicken data. The chicken data, we've used this glob and everything with a 1 or 2 in that position, .fastq and a view. And when we run that, we get this these tuples return, with the first part being a value, which is the base name, followed by the two file paths, which is there. So as you can see, gut, liver, and lung, which are those same files that we've seen up here. Now, what we can do in this situation is, you might think, okay, this is great, I've got my files in, but they're not quite, you know, the tuple isn't quite how I want it to be. We've still got the two paths as part of the second part of the channel rather than separate parts, and I don't want that for whatever reason. So again, there are ways to kind of, there are options to kind of reshape this. And the first is flat. And flat's a really cool example of how you can sort of reshape this just straight away on the fly as the data is coming into the pipeline. So again, this is pretty much exactly the same bit of code that we've just used, which we're just going to be using from file pairs. This is the file path using glob 1 and 2, but we're going to add this option of flat. Now, I'll run this quickly and then give you a couple of seconds just to see if you can spot any differences. Okay, so what you've hopefully noticed is that up here, when we didn't use flat, so this is the first example, we didn't have in a weird way, we didn't have this flat. She'll remove this one just to keep order. You'll see that everything here is this is one sort of pair of brackets, but we've also got this other one, meaning that this other set of square brackets, meaning that these two paths are effectively in the same part of the channel. Here, for example, we'll split this out into gut 1 and gut 2. So the gut one is the value, and over here we've got these two paths with only one set of brackets. So it's effectively said flatten each channel so that everything inside that channel is its own element or own part of the channel. So this is just using flat, which is an option. Of course, there are other options here. Again, type hidden, max depth, all these different things that you can really use to specify what you're including. We don't have time for this today, so I'm just going to skip over it, but you can basically bring data straight in from NZBI SRA archive. You can just use like an API key and just specify which data you want in. This is especially useful if you just want some supplementary data for your analysis or something like that. You can just bring it in straight away using something like the channel factory here from .sra. So again, like from path, you can just bring this in. Here it is automatically sort of splitting this out into a value and the two paths, much like what we saw from the from file pairs. It makes all these nice little channels that you can basically use in your analysis and feed this straight into your pipeline. No extra work is required, which is really, really cool. Okay, so I think this is important, so I don't want to skip it. But when you can think of situations where you're not bringing in necessarily a data file, but you want to bring in like a spreadsheet. And this is particularly relevant, like if you're using like an Illumina sequencer, for example, where you might have like the sample sheet that has been fed into the sequencer, and now you think, okay, I want to use that same sample sheet to import some of this data using, so I can feed it through my pipeline. So what you can do is use sort of the channel factories in addition to other operators to really sort of manipulate this, manipulate what's being brought in and how it's being brought in. But this time we're actually going to be doing it from a text file and addressing different parts of that text file. So you could imagine that this would be like each sample is a different, each line is a different sample in that sample sheet. So here we've just got a random text. So we'll quickly look at that. Data. Actually, meta, isn't it? Where is it? Data. We can go over to meta, random.text, and you'll see here that it's just a effectively just a bit of a paragraph of different lines all separated out. 7 different lines with just some text in it. So when we run this using the snippet, again, I'm just using the snippet. You could have created a different .nf file and executed it from that. But just for the sake of keeping everything similar. Cool. So what's happened here is we've gone, it said from path, this file is obviously a relative path, and the data meta random.txt file, which is what we've brought in. And we've used this split text. So what split text does is it separates out every line in that file as a different channel, and we've just viewed it. And that's effectively what's being said here. It's split each item into chunks of 1 line by default. But of course, you might have a slightly more complicated sample sheet. There might be something like doing something a little bit out of the ordinary. So much like with the other sort of channel factories we've talked about, you can actually sort of chain different operators together and use different options to sort of really sort of manipulate how all of that information is coming together. So again, we're just going to run this quickly. And here it's just split it out every line, and we've used the subscribe operator just to, we're saying print out each item, and then after each item, just print out end of chunk, which is what's happened here. So we're splitting the text 2 lines at a time. This is an option for split text. Subscribe, which is how it's going to be printed out. And here we've just sort of said do this at the line, at the end of each line, which is what we're seeing here. Okay. So this is where it gets a little bit more complicated again. We can keep adding on different operators and tuning different parameters, or different options rather, to keep kind of compounding, different ideas or manipulations that we might want with our data. So again, I'm just going to sort of keep demonstrating different ideas, and I just want you to keep thinking about, or I'd like you to keep thinking about how you could use this in your own analysis. Here, for example, I can't think of a real world example for this, but maybe if you're dealing with some sequence data that you wanted to get to upper or lower case for whatever reason, you could say, bring in my sheet of data, my file, my FASTA file, doesn't really matter what it is. I'm going to split it by chunks of 10. So I've got the 10 lines or 10 parts here. This is probably, you can just do it by 2 or something. That's probably a better example. And then split it into, or change each item to uppercase. So again, like, it really depends on what situation you're in and what you're trying to do with your data. But Nextflow has a lot of really powerful ways to change this so that you can sort of modify the data coming in, or once it's in and you want to sort of change it between 2 different channels. There are lots of different ways to do that. So here is just a simple example in a way using this random text, but there are lots of other ways to do it. You can also make counts or something else like that for each line. So say you wanted to kind of count what you're doing or ascribe a number to each as you're working up. So here you can use this count ++, which is a little bit more sort of codey, I guess, than some of you might be familiar with. But again, we're using this kind of compounding idea of adding. We're going to create this channel from path. We're going to split the text for here without any other operator. It's just each line, and we're going to view that by printing out a count, which starts off at 0. Then we add 1 each time. This might be unfamiliar, so don't panic if that's a little bit strange. We're going to convert it to uppercase and trim the text as well, so we don't have any extra white space. Again, just an example that you can have very powerful manipulations. Just for time, we're going to skip over quite a bit of this, but another common application is to use like a .csv. So up until now, we've been using a text file, which is that random text. A CSV might be a much more familiar example that you might use in the real world. So here it's just one of the CSVs that is used in the example. So patient 1 and patient 2. We've kind of got this data here, which you might expect to be something similar to like real world biological data. We've got patient ID, number of samples, manual failed regions, and just all sort of comma separated text there because it's CSV. We're just going to pick one example. We're just going to choose this one. Oh, clear. So again, we're just going to say from path, instead of split text, there's split CSV, which is obviously slightly different. Here we're actually specifying that the header is true. So this is an option that might be useful if you are importing your own data. And this is just saying that the headers obviously are true and they do exist. Here we have rows, and we're going to each line or each row is imported separately. So here we've called it row, but you can call this anything you want. So let's call it TT. Import that as using view. So here we're just looking at the two different, effectively the two different rows. So we're remapping this. We will talk about mapping very soon, but we're saying for each row, use patient ID and number of samples from the header, and you can use that to basically just pull out the columns that you're interested in from that CSV. There are obviously other options that you can do here. You can specify your own channels. So you can sort of say, I'm going to call it column 1, 2, 3, 4, and 5. And then when you're using this view here and remapping, you can just say row.column1, which is what you've called it yourself. You could call it column A, B, C, D, and E, call it column A and column D here. Basically, there are lots of different ways that you can bring in a sample sheet and sort of really choose which parts of that sample sheet you'd like to look at one time. So down here, there's an exercise which you might want to come back to later, but it's effectively asking if you were to try and write a sample sheet. So you would go away and write the sample sheet, sample sheet.csv, and you were to try and bring that in using split CSV. How would you do that? Would there be any, how would you sort of shape that data? As a quick note, you can also import Tsv files, so tab delimited files. Using the split CNV, you can add the option, which is sep /t or /tab, just to separate that data. And again, it just really depends on what your data looks like, what you're trying to bring in. What I wanted to sort of stress here was that there are lots of ways to bring this data in. It's a really powerful way of doing this. You don't have to go away and write like a custom script to try and pull out just the bits of data or names that you want from those files. There probably will be a way to do it in Nextflow. I'm not going to guarantee that there's always a way, but I think just about every use case we've ever come across, there is a way to do it with Nextflow. And it's a really effective way of doing it if you can use these sort of channel factories in the right way. Unfortunately, I won't have time to go through this in detail either, just because I want to keep things moving. But if you do have more complex file formats, you can bring in sort of JSON files in different ways. And this is quite a popular way of doing it, but it's probably a slightly more advanced way of doing it as well, which we just don't have time to sort of cover in the detail I think it deserves. But if that's something you are interested in, you can go back and check out this section. If you want more information, or if I've said something that doesn't quite make sense, of course, here in the Nextflow documentation is information about the channel types, the channel factories. I think we sort of touched on value from list, from path, from file pairs. We skimmed over SRA. there. We didn't really touch on binding values or observing events, but there is a huge amount of documentation and there's a huge amount of sort of functionality with Nextflow. So we just, like I said, we kind of having to skim over some of that right now, but I do really encourage you to come back and check out some of this documentation in more detail. So we are going to jump into scripts, not scripts, into processes. So this is going to be, this is going to be section 6 in the training material if you're following along with that. As we've already sort of talked about, each kind of sort of, if you're bringing in a tool or you're trying to do, a task, you kind of wrap it up as a process and you give it a name. So here, for example, this process is the index, or we've called it index, and we're taking the transcriptome file and we're indexing it and producing samma.index being the output. So just as we're going through this, think back to how we've done this in our sort of proof of concept example. Okay. So this is probably a lot nicer way of saying what I've just said or tried to say. In Nextflow, process is a basic computing primitive to execute foreign functions. So like I said, it's really just a way to execute that script. In its absolute simplest form, you could just have a process such as you could call it say hello with only the script. You don't always need every different part of this process block, because up until now we've talked about directives, inputs, outputs, and the script, but there's also when, which is something we haven't talked about, and we'll touch on here a little bit. But ultimately, you can just get away with just the script block, which is what's happened here. So you could just say process, say hello, script, echo world, and in that workflow block, which is the same as this one down here, you could just say, say hello, round brackets, and it would work, and it would just echo hello world. So taking a wee sidestep, when we think about how to structure a process, we've sort of seen already that you can have these directives at the top. A lot of this is more convention than necessary. You do need to have the script block at the bottom, but these others you probably can move around a little bit. Not always, but sometimes, depending on what you're doing. But whenever we call a process, so again, this is that simplest unit of what we use to actually execute the script. Process, you can give it a name. What you might have noticed is that we've kind of capitalized all of the names here. This is more convention, but I find it quite useful so that you can easily separate out what's the process and what is potentially a channel, especially if you're not using like a naming convention like quant_channel every time you have a channel. Like example, if you were to have that, it would be very hard to tell it apart if it wasn't capitalized. Okay, so this here is just kind of explaining like loosely what I've already said, is that you can have 0, 1 or more process directives. You can keep stacking these if you've got different things you want to sort of control, so CPUs, publish directory, are some examples that we've already come across. You can have 1 or more process inputs, or 0, 1 or more process inputs, so you don't actually need the input. Same for the output, you don't actually need that if you've just got a simple example like echo hello world. When we haven't used yet, but when it's basically like if this condition has been met, then do this. And this is actually the script block here. So up until now, we've just been using script, which we'll just go back and look at here, script. You don't actually need that in the script. By default, it will just be script. But for, you can change this out to be something like shell if you want it to be a shell script there as well. But I'll touch on that in a second, actually. So we'll start off with the script block, just because it is probably the most important, and I'll kind of explain what I started rambling a little bit there about. But a script block is a string statement that defines the command to be executed by the process. So here in this example, we've got this process, which we've called example. And we've got this block of text, which isn't anything sort of out of the ordinary. So it's just echoing hello world, new line, hello Mundo, new line, ciao Mundo, hello Welt. And we're just going to put this into a file. We're going to cat that file, use a couple of heads, and then take out chunk_1.txt, and then we're going to gzip it. So in a script, you can have multiple lines of code, multiple tools. As a rule of thumb, you should try and make your process as simple as possible, and you shouldn't try and sort of include too much into the one script. You can, but it's much nicer to separate these out as different processes, so that when you are executing that Nextflow workflow, if it needs to, it can parallelize those different processes, and you can ascribe different resources using directives, which is something we'll come back to as well. Anyway, just to show this as an example, a quick look at what we've actually got in that working directory already. Okay, so the workflow has run the process example. And what it has done is run the script block. You can see here there's no input or output. So this is just a really simple example. And we can see what else is in here. And as you can see, there's nothing, nothing new. So we don't see a file or anything like that. And that's partly because we haven't actually set the output directory or published directory. But what we can do is go into this process and actually look at what's happening. So as Evan sort of mentioned right at the start of day one, everything we do is kind of cached in this work directory. And we could use this hash number to access that. So here it's 37616, 37616. And we can see in here that we've got chunk1.txt, chunk.archive, as well as this file, which are kind of like the three outputs of the script. We could also look at what was actually run here, which is command.sh. Oh, that's not quite right. We want to cat that. So you can see here, this is actually what was spat out from the actual execution of the command. And all this is archived in these files, in the work directory. Everything is staged there, so we can go back and look at everything that was there. It's a pretty good way to look at it. So you can see here, we've got some hidden files, which are the command.sh to run the log, the begin, the out, and the error if there's any. If you ever have any trouble with what you've actually run in the script, you can go back in here and look at all of this. I find this really useful for debugging when I've had something that's failed. Okay, so here we've just used a script. This will all make a little bit more sense very soon, but you can also add in different languages at this point. So say you want to use an R script or a Python script, you could write basically the shebang for Python at the top here within the script block, much like you would in Bash or another script, and execute it in the same way. So again, I've just copied and pasted this in. You're welcome to do this at home as well. Script, Python shebang, and our Python sort of code, just saying hello world, and we're going to print that out to the screen. Snippet NF. Cool, and it's just executed that, but we won't go in and actually look for that little bit of code. Same thing here, we could do a very similar thing, and that you could just sort of take in a parameter which was set here using params.data. Here we've just specified it as a variable in the script block. So we're taking this from outside of the process, we're using it in the process, and then we can just specify that, or that can be accessed directly as a part of the workflow script. The main thing in this next little sort of block of text, so there's lots of different examples that you can use to kind of show this, but sometimes you might need to escape kind of the Nextflow script. So say you were trying to use a path directory from your local environment, or trying to specify your working directory or your PWD. You need to escape it, and you can do that using a backslash. So this is where Nextflow kind of meets your local system in a way. So if you were to run something like this, I'm just going to kind of, so if you were to run this without the backslash, without escaping, we'll see what we get. It still runs. Debug. Cool. So what we've done here, and what I've done is just add debug at the top. So debug is quite a nice way of actually just printing out everything that's happening in the script. We will use this a little bit later as well, but here what I'm doing is just basically using it to show what is happening as a part of the script. So let's compare what's happening here and here and here. I've done it the wrong way, haven't I? Okay, so what you'll see here is that the outputs are a little bit different, and that's because we've effectively escaped out this working directory PWD. So I've got quite a bit of extra code in here, but when we're using it with the escape, you can see that we've actually, the working directory is actually the work directory where this was happening. So this is the same location, 11 AFD, that is happening here. Without the escape, you're just going to be using the working directory that the command was executed from. So this is really just to demonstrate that depending on if you are trying to specify the working directory you're in, or potentially what's happening within the Nextflow sort of environment, you may or may not need to escape what you're doing to use these commands that you would have otherwise used in your bash terminal. So that's also similar, like, for example, if you were trying to create a new line, you'd have to escape that part of it to be able to do that. Here, up until now, we've talked about the script block. You can also use a shell block. So you can use a shell statement instead of the script statement to use a slightly different syntax. This allows you to use both Nextflow and bash variables in the same script, which is what we can demonstrate here. So basically now, because this is a shell over script, we need to specify that Nextflow variables are kind of like secondary to the bash variables, meaning that we need to escape using this exclamation mark and wrap it up in these curly brackets. I'd really encourage you to sort of play around with some of this stuff. It is probably one of the more common things we find if people are having problems with escaping out of or using a bash variable as a part of Nextflow, which there are lots of good reasons to do that, especially when dealing with a full data pipeline. But yeah, just remember that it's probably going to depend on if you're using a shell script. You'll also notice here that these are single rather than double quotes, but it's probably to do with this exiting out. Yes. So very quickly, conditional scripts. This is basically just creating if-else statements, which is saying, if I've got my input file and it's being compressed, so my parameter said that it was compressed, then do this. If it's not, and it's a BG if rather, it's a BG zip2. Again, this is a parameter that you can set up here. Do this, and otherwise throw an exception that is an unknown aligner, and that params.compress. So that was just print out to the window, unknown aligner params.compress, which would be whatever this is. So if you put Chris or something else in there, it'd be a little bit different. And of course, just the workflow script. So I'm just going to power through, hopefully, the inputs and the outputs before we take a wee break, and then we'll come back and talk about when directives and organized outputs. But yeah, okay, so Nextflow processes are, they're isolated, and that's how we can make everything parallel from each other. But because they are isolated, sometimes it's difficult to communicate, or you might need them to communicate, and that can be a little bit challenging. But because of that, we just need to send values through the channels. So when we specify an input, we need both the input qualifier. So this is, we might say something like path or value, and the input name. So we had a question yesterday, which is, is there a good way to know exactly what you've got in these channels and if it should be a path or value? The short answer is probably no, but you can sort of work it out depending on what was the output of the last process and what's in the process of the new input. Chances are it would throw an error and tell you that it's an unknown value or path type, depending on quite what you're doing. But I think the easiest way to sort of demonstrate this is just to have a look at some examples. So here we've got this channel of 1, 2, 3. So remember, this is a queue channel. We've got this process, which is a basic example. Debug again. So debug it's a little bit like echo, that it's just going to print out everything that I'm sort of pumping through. We've got input, a value of X, echo process job, variable X, which is what we specified. This doesn't have to be X. This could be value hello. And this is just to demonstrate that you can just kind of call this anything you want. In the workflow script, we're going to just use basic example num, which is this the channel that was set up here. Oh, yeah, that's my bad. So I didn't name that properly. And you can see here that it's given me a nice error message, basically saying that this is unknown, and I need to check the script at line 10, which is just giving me the start of the script block because that's where it fell over. Cool. So it's just run 3 times, saying process job 2, process job 1, process job 3. This is the sort of FIFO part of a queue channel, and then it's just first in, first out, so it's not in the same order as you might expect up here otherwise. But this is just an example that we've set it as a value, even though that we do have, the channel is an of, being a queue channel, it's not a value channel, but each element of this channel is being treated as a value, which is a subtle distinction, but it's an important one. Otherwise, you'll probably run into a few errors along the way. If we are going to use an input file, so an actual path, so up here we've specified a path, we can see what's going to happen here. So again, it's path, debug true, so we're going to print it out. Here I've specified the qualifier as path, and I've given it this sample.fastq. Again, we could change this to whatever we want. We could just call this fastq. fast Q. Again, we can just change this as much as we need. And here we're just executing the process using foo, which is the process name, and reads from the what we specified in the channel up the top. Cool. So as you might expect, because we've got this glob pattern, we're actually going to print this 6 times. If we were just to kind of call that gut underscore 12.fastq, we would only expect to see it twice because there's only the 2 gut files. Okay, what do we have here? So I think we kind of covered that. Yeah, so this is probably the next thing, is that you can actually use the same idea to create like dynamic file naming. So in that first example, we've just used sort of this fixed fastq output. So we've just basically asked for ls fastq each time. So it's not going to have a dynamic name based on what was actually imported in the input. But you can also use the input path, we call it sample, and then here when we output it, we can use this effectively variable sample to help name it. We've also got a collect operator down here just to kind of add all this together. So here, for example, I've just used LSLH with the sample just to give us each output, which would be a little bit slightly different, but to kind of build on that, like I said, we've got this collect, which is sort of added all of these together on top of each other. It's not one element; they are still separate, but it's just printed them out in this kind of list format. Again, I think this will pretty much be the same thing. Which is just going to ask for that sort of dynamic name of genome, which is coming from the input, which is based from up here, which has been set up here as a parameter. So it's taken the parameter, it's given me taking the path as the input, so again, it's that qualifier. It's pushed it through the script using the genome, and it's going to execute the process on that. So it's very rare that you would only use one input in isolation. In the example that we've been using, it's been like the transcriptome file. In reality, you'd probably have multiple inputs at a time. So here we've just specified 2 sets of values. We've got X and Y, and we're just going to echo those out. Again, we've got the debug to actually show this to the screen. If you didn't have that, you'd probably need to do like something like a view.view, but we don't need to do that here because we've got the debug. Which again is just, like I said, an echo. Cool, and as you can see here, it's just taken these and spat them out. What happens is it's going to take, the channels have to be full for the process to run. So when you have 1, 2, and 3, you're going to get a nice output for 3C, 1A, and 2B. Because these are queue channels, it's not in any particular order. But what happens if we sort of take out one of those values? So there's 2 in one and 3 in the other. You'll see that it's only run twice. And this is because the channels weren't filled. We could do this in the other direction and sort of add 1, 2, 3, 4. And we'll see something similar, but kind of the opposite, and that we'll see A, B, and C, but we won't see any sort of trace of this 4. And this is because these are the queue channels and then they can be used once. But if we were to change this to something like a value and just call it 1, so you can see here that the 1 has been used multiple times. This is because it's a value channel and it can be consumed again and again. And this is kind of an example of why, when I was talking at the start about understanding that there are subtle differences between a value channel and a queue channel, will influence what you can do later on in your pipeline. Yes. So this is basically what I've shown here already, using a slightly different example that we've used a value of 1, and how we can use that to generate slightly different outputs. Okay, so this is another kind of slightly more advanced example in a way, which is for time I'm not going to go into too much, but you could use this thing called each. So each will sort of say, run this for each of these. In this case, it would be saying, run this process, which is called line sequences. Excuse me, for each of the modes. So modes is the second part that we're sort of adding into this process. So this would be for methods. So sequences refers to the paths, which we've added in here, and each mode is going to be for the methods. So when you run this, it'll run it each time for each one of these different methods. And that's a really powerful way of, say you had different aligners or different chromosomes or different, different anything that you want to sort of run it multiple times and test it in different ways. It could be different sets of parameters. You could specify all of this, use each to kind of sort of drive it through multiple times. Okay, outputs. So outputs are, for everything that comes in, quite often you want to have an output. It's specified much the same way as inputs, and then you have a qualifier as well as what you're actually calling it. There are different qualifiers, so value and path are probably the two major. But we also have this thing here called emit. So when you use an emit, you can, which is specified by after a comma, you can say emit and give it a name. Emit is basically used to name what your output will be, and this will become more relevant when you have multiple steps or different outputs that you want to name slightly differently, so that you can sort of bring them into a different channel later or add them into a process later. And this will become more obvious in a second. So again, just very simple, excuse me, simple workflow. We will sort of set methods, which have specified this list. We've got the inputs, which is a value. So we're treating, as it comes in here, using foo. It's treating channels.of methods as it was a list, but because we've used this channel of channel factory, it's going to become a queue channel. Again, this is kind of where these concepts get a little bit like blurred and muddy, but I assure you it does become clearer with a little bit of practice. And then we're just using a receiver.channel. So we've specified, or we've called this, or we've made a channel called receiver.channel and reviewed it with this again. So received, and it's just going to print out each of those. So it's treated it as a list. It's come in, it's treated that whole set of things as a single item, even though it is sort of a list up here itself, and it's just printed that out, and that's what we've seen here. So it's received this as a list. I guess we could try and change this to something like from list. I think that's the right one. I'm not sure if this will work. Yeah, okay, so because I've used from list rather than .of, I've actually split this out into three different channels because I've used a list rather than of. So that's just a slightly different way of doing that. And again, it's just to demonstrate that you can sort of manipulate these things based on what you're trying to do. Okay, so here's an example where we haven't actually got an input, but we've used we've just basically set the output being results.txt, and we've used echo random to basically pump something into the results.txt. Just for time, I'm not going to go into that, but what I did want to show is that you can still use glob patterns to specify multiple outputs. This is much the same as when you specify a glob pattern with your inputs. You can do that so that you're not necessarily worried about this here. You're just sort of saying anything with this pattern is fine. And that's what we will see here, that we've printed holler, and they've split it out into chunks, and we've just called it chunk 1 with the letter at the end of it. So chunk A, B, AA, AB, AC. We've run that. We've also used a flat map just to separate those out, and then a view just to view that. Okay, so we're just going to sort of jump into this probably slightly more advanced process just to kind of check out what it does, and we'll dissect it. And I'm hoping we will sort of cover a few of the concepts that I've briefly alluded to already, but also give us opportunity to I'm sure that failed. Sort of talk about a few of those concepts in more detail. Okay, so the cool thing about Nextflow is that you quite often get like a really nice error message, and it'll tell you potentially what's failing. So it's missing an output file called this. It was expecting this and it couldn't find it. And it was expected by our process align. So we know that something's gone wrong in this align process. So let's just try and debug that now. We've got this process align, input value X and value seek. These are just arbitrary names, not too worried about that. It is looking for this sort of variable, which is X, being this input here. It says dynamic.align. So it is expecting to have these three items as a list. So I think that's the mistake. .align, I would have expected this to be separate. So what I think needs to happen is the same as what I've already done just previously, is that this shouldn't actually be an of, this should be a from a list, so that each of these species is treated separately rather than collectively as a single list. So that's just kind of splitting those out so that they can be used. Yep, and I think that's worked. So the issue there was just that this here, the species, this is a list, and it didn't like that because it was expecting that list to be called basically as it was almost treating it like a string, right? So that instead of splitting this out so that we could get each of these separately, it tried to do them all at once, which is a little bit strange. This is an example that we'll need to go back and fix in here. Okay, so slightly more advanced option. We're going to be using tuples here. So just a reminder, tuples is when we have sort of multiple parts to a single channel. So thinking back to what we did with the from file pairs, we had the value at the start being like gut or lung, as well as the two FastQ files at the end. We're doing the same thing here. So this is the sample ID, or we've called it sample ID, which is value, as well as the paths, which are those two file paths joined together in that kind of like list square brackets. And what we're doing here is we're going to take that as an input. We're going to basically use echo, your command which is arbitrary. This is all just arbitrary code. Read sample ID into sample.bam. So we're not actually going to be really using the sample ID, or nothing's going to be happening to these, to these files, but we're just kind of using this as a demonstration of using it as a silly of me, as a dynamic kind of naming situation. Nextflow, run snippet.mf. So here we've reverted back to using a view. We've taken away the debug up here. It really just depends on what you're trying to do when you're sort of developing. If you just want to chuck in a bunch of views, which I wouldn't really recommend because they're a bit of a pain to get rid of, but the debug is a pretty good option. So here, we're taking the output, which is the tuple, so the two different parts. We've got this value here, so we've got a value for each of these because it's used this twice because we've got this sample ID here, which is a little bit strange. I'm not sure why this example is like this, because we could just use this, for example. We just might want to do this and run it again, but effectively what it's done is it's just said take those two files, which is the sample ID, which was there previously, over here, sorry. It's called it that, and then we just created a path to this arbitrary file, which is called sample.bam, which is what we've created here. But of course, like depending on what you're trying to do, just as again a very arbitrary kind of way of doing this. We're just going to run that again. So I've changed this from sample ID. Sample ID is still being used in here, but we're just taking sample here directly to the output. So this is like an example where you might just use this as a sample name, which you want to carry around with the sample for the entire thing. We've got lung, liver, and gut in here as well. So this is just a way of sort of saying when you have a tuple, you can kind of like mix and match different parts of it, either in your script block, input, output, whatever. As long as these are unique names, you can kind of like mix and match them. There's probably a bad example on that. You might get confused between the sample and the sample.bam, but you could just call it something like that and it'd be absolutely fine. Okay, so we're about an hour and a half in, so we're just going to take a wee break for 5 minutes just so I can catch my breath. We are running a little bit behind, but hopefully 5 minutes is long enough for you guys to go away and get a drink and stretch your legs or go to the bathroom, anything like that. So I'll see you back here in 5 minutes. Okay, everyone, welcome back. Just another maybe 10 seconds, and then we'll get straight back into it because we've still got a lot of content to cover. Okay, so just a reminder, we're working through the content in the training material on the training.sakura.io. We've just sort of finished talking about outputs very briefly, and we're just going to jump straight into using when directives and how to organize outputs very, very briefly. So when is basically just another part of a process block that you can use, where you can set basically criteria to say when this occurs, or when a name is finishes or starts with whatever, and this equals this, then actually execute a script block. So it's kind of a little bit like an if-else statement. I'm not going to go into that today, just to kind of keep things moving, but this is a whole nother block that you can add. There's a little bit about it here. Of course, there's more on the Nextflow IO documentation page. Much the same for directives, just for time. I won't go into every possible kind of directive that you can use. The main thing to remember is that you can conventionally, you'll mostly add these to the top of your process block. You can add in different things to kind of control what's happening in that process or fine tune it. For example, CPUs, memory, you might add in a container. So you might set a specific container from Docker that you might use just to control this image. This is something that's really common for NF Core, as well as a really popular convention for most pipelines, actually. And then you can just sort of add in your inputs, outputs, scripts, and things like that. That's all pretty straightforward. Just as a reminder, we have used directives. That was one of those words I threw around yesterday in script 7. Tag here is another example where we've added a tag to the end of what we're seeing in the command line block, or the command line when we're executing the pipeline, as well as the publish directory, which is another good one to use when writing a process. Organizing outputs is another good thing to do. Again, just for time, I don't want to spend too long on this, but you can basically use like publish directory, which is something we've talked about previously, and we've just demonstrated. But depending on if you're using something like an S3 bucket on AWS, this can get a little bit more complicated. As a rule of thumb, just name it sensibly. This is probably what most people will use as a sort of a fallback option, just publish a directory using copy. But some of you may sort of look for more complicated semantic subdirectories, and there are lots of ways to do this, where you can sort of, based on the parameters or different patterns, you can specify, where you would like files to go. And this is really common, like, for example, if you run a process and it might create like a VCF file, thinking about biological data with a bunch of other data just created as part of that process, you might try and sort of send those off into different folders based on what you're trying to save and keep and do with them in the long run. So just for time, I won't go into sort of all the patterns for this, but this is a really good example here that you could play around with, just to kind of see how using these glob patterns as a part of the publish directory, using patterns as an option to publish directory, you can really sort of direct where you want to save that data. So probably the hardest concept to grab when learning Nextflow is about operators. So operators are kind of, they're really used to manipulate and control what's happening with your channels and where different parts are going. But there's also a lot of options which you might not sort of realize in terms of actually using maths operators to control or to change numbers as a part of those channels. So as a basic example, new section. So you sort of start off with like these simple examples again. in its simplest form, Nextflow runs snippet.enf 14916. So what's happening here is we've got this channel of, so it's a queue channel, 1, 2, 3, 4, different numbers all being treated as a separate sort of item. We're going to create square, so it's nums being this channel, and we're going to map them. Map is a really common operator. I think map is probably operator that some after you've defined your channels. Mapping is a really common way of sort of restructuring the different parts of your channel. So you might say, okay, I no longer want this, so I'm going to remap it and remove this. Here we're just using it as a way to effectively take each item of this channel and square it. So times the item by the item, and then we're just going to view it, which is happening here. So because we don't have a process, we can't use debug, and we see 14916 as the outputs. Here's another example, but this time we're going to be using sort of separate strings, and we're just going to view them just as an example. But we can also refer to these different items in the command block like this. I've just added in space here. You don't actually need to do that. It's really just however you like to sort of show your code. I like having a few gaps because why isn't that working? Yeah, something silly. Yeah, so this should be curly brackets rather than round brackets. I should have checked that. These are used sort of differently. There probably are like set rules about what you can and can't do. I still get them confused time to time. But the easiest thing to do is just sort of remember them sometimes. Is that largely when you're using it, it is going to be these curly brackets, or an item rather. So what this is doing is just as a part of this sort of script block, adding this basically we hyphen at the start of each item, so when it's printed out, we see it as a nice list. And this isn't much different to what we're showing before, where you could say, you could add anything there that you want just to make it a little bit easier to read if you are printing it out, or if you're trying to split this into another, or trying to pipe it into something else, you can add some text there. So as I sort of touched on already, the map operator is really, really powerful. It can be used in lots of different ways to kind of take an element or take a part of a channel. So channel.of, and we've got these two different things in here, two different strings, hello and world. And we're going to take each of those items and we're going to spit it out, but in reverse. So reverse is a slightly different operator here, but it's just to kind of demonstrate that you can take these items, and using map you can basically use different code or different operators, or it really depends on what you're doing, but you can use it to basically manipulate what you're going to see as the output when using view. So taking the item, and then we've used the item.reverse, reverse being the operator, and it's flipped it for us. And of course, there are lots of different operators that we can use. Another one here that we're going to use as an example is .size. So instead of using it, we could use it in all these different situations, but we've just arbitrarily changed it to Word because it's a little bit easier to potentially conceptualize. Hello.world, Word, and then we're going to have Word and word size produced as this two parts of a list. And then we can take that using view, and we're going to use Word, and then basically create length, and then we're going to sort of show the first part, which is Word here, or here rather, contains length. So this is we've kind of arbitrarily named these again as word and length, and we're going to sort of remap those as a part of the string as word contains length letters. So let's just see that. Hello contains 5 letters and world contains 5 letters, but we can just add in as many letters there as we want. You can change this up to be anything you want. Just going to treat this as a variable. You could add in. You can use some of these more than once. There's a lot of like different things you can do with this. So, you can see here, we've got this, world random letters contains 15 letters and 5 letters and hello. There's lots of different things you can do with map, just to kind of like take this, and then when using view and remapping inadvertently as a part of view with the curly brackets, you can sort of fine tune control different things. I've seen a few questions about kind of the difference between things like mix and collect and flatten in the Slack channel. So hopefully some of this will help clarify this for you as well. But we have C1, C2, C3, different channels, 1, 2, 3, A, B, and Z. When we use mix, first of all, it's taking all of these and kind of just mixing them together. So they're all going to be printed out as a part of this view, but they are not one channel. They are different items. They still exist kind of independently still. They are all getting printed out together, but they are still separate items, I think is probably the right way to describe it. And we see much the same thing here, but it's a little bit different when we're using these list items. So this is different to what we're just showing here. We've got channel of here. See my history. You can see here that we've got these lists. So these aren't channels, remember. These are just kind of like set strings almost. So we've got the channel of fill and bar, so we can import both of these or add these. Well, these are going to be used as Q channels, but they're going to be they're still lists, but they're going to be trying to think this way to describe this. They're going to be treated differently. Okay, we'll do this, and hopefully a little bit easy to explain. So using flatten here, we are going to be separating out each element of these lists. So we've got kind of like list 1, foo, and list 2, bar. If we weren't to have this, what we should see these are still contained as the list, so they haven't been separated out. So flatten is taking parts of those lists and separating them out for us, which is quite nice. So if you've created a list for whatever reason, or imported something as a list, or it's been sort of forced as a list for whatever situation, you can see that separately. Collect is the other big one that I think is quite common. So we used collect at the back end of script 7 when we were using this multi-QC. So again, we mixed these two channels. So we mixed the quant channel was mixed with the fast QC channel, and then we collected them, and just to combine them all into one single channel. And what we can see here is similar things. So we're going to run it again. So we've got 1, 2, 3, 4, collect. And what should happen here is this will push back to us as one single channel. It's all been collected together. And this is in comparison to if we didn't have that collect, where each of these is going to retain its own line as a separate channel there. So we also have this thing called group tuple. So again, tuple is that word that we've been using to sort of specify we have different parts to a channel, and the first might be a value compared to a pair of paths or some individual paths, like we saw with the from pile pairs when we're importing that the chicken fast queue data. So what we can see here is we've got a channel of a series of different tuples. And what we're going to use here is group tuple being the operator and view. And what we can see happening here is it's going to group the tuples based on the first element. So in this case, we've got sort of A, B, and C all grouped based on the 1. We've got the 2, C and A, and we've got the 3, D and B. There are lots of different ways to group a tuple. Again, there might be lots of different scenarios where you might want to do this. An example might be if you've run some sequencing analysis and you've done multiple lanes of the same sample on different runs, and you want to sort of merge all of this based on the sample name or something to that effect. So you can see here that we've got the same output, which is really nice. There's a nice example here. We exercise if you want to have a go at that in your own time. We can also use join, which works pretty similar, but it's sort of just going to use a matching function. So we see here we've got these 2 different channels. So it's these Q channels, X, Y, Z, and P, Z, Y, X. And what it's done is it's just basically joined all of these together. So every time it's seen is joined on the right. So you could change this left join right. It's a little bit backwards, isn't it? But when you have the left and we're joining the right, and then we can view it. So it's joining this left and it's joining on this channel of right. And then we can view it. So you can see it here that we've got this Y, 2, and 5. So you can sort of see here Y, 2, and 5. So it's taken this and it's added on this because we've joined right onto left, which is super confusing when I say it back like that. But I hope that at least it makes some sense to someone. Cool. So branch is another operator which is really useful. So this might be a situation where you have like big and small numbers, and it might be a do this if the file is over this size, or do this if it's under this size, or if there's this many lines, or if the sample is this, then sort of send it this way, otherwise do it that way. Here we're just using a very simple sort of branch operator to specify either small or large using values. You could kind of do like a string match or something else in this situation as well. So this is something that we haven't really talked about, but when you have a channel like this, you can kind of add on these other little bits here, which can be used to define, in this case, which branch we're looking at. So like you don't even need this part here. You can just say, okay, I only want to look at the small. This double line here is comments. If I haven't mentioned that before, I can't remember if Evan talked about this in his talk, but you can comment stuff out just using a double dash like that. But this one just refers to this branch here, and this is this branch here. This isn't really covered in the material, but I mentioned it earlier that you can use an emit with your output. And if we've got time, I think I'll come back to that. I'm kind of surprised it wasn't in the content here. Maybe it comes up later and I've skipped it, but doesn't really matter for now. But basically, you can use this to specify which branch you want to be on. And as you can see, you can use it to add basically text or do different things based on what has been sort of included here to decide if it's small or large in this case. So that you can imagine a situation here as well. You say, okay, I'm going to take this small, treat this as my new channel and pump it into this process, but all the large stuff, I'm going to pump it into this process. So you can really mix and match with that. So there is a huge amount of information about this, and I've really only sort of skimmed over the top, and it's a bit of a shame, really, because there are so many really useful operators that can be used depending on what you're trying to do with your channels. Some of these are already sort of talked about with like split CSV and split text. We talked about those in the last section when we were looking at kind of like controlling the inputs from like a sample sheet, for example. But there are a huge different number in here. And I really encourage you to go away and have a look at some of these just when you get a free minute. I can't sort of speak highly enough of the content that's actually in this, excuse me, in this documentation. The examples are pretty good, and you can sort of go in and see examples like this. Just when you're a little bit confused, you're not quite sure how to do something, a control search will generally get you to where you need to be in the different data. So normally when we run a training like this, we would have time to go through the Groovy basic structure and idioms. Today we are effectively just going to skip over this completely, and it's quite a common question is, do I need to know Groovy to write Nextflow? And from my experience, I think the answer is no, but it does help. So understanding a few, like print line, that's very Groovy. We've got, you can sort of use definitions, how a list works, how assert works. Even little things about like multi-line strings. We did this in our log.info at the start of our NAC pipeline. There's just like a lot of like little things like that do come up, but I don't think the concepts are beyond kind of a quick skim of this documentation. It might take you sort of 60 minutes just to kind of push your way through and understand some of it. Some stuff here about like the curly brackets and round brackets. Really useful, but I just don't think we're going to have time to we don't have time to cover it today. So we're already quite a wee way behind on the schedule. So what I'm going to focus on here is just kind of potentially the modularization and a little bit about Nextflow configuration, and then also just talk for 5 minutes about these deployment scenarios, about how different sort of HPC systems or clouds can be used. But we're just not going to get to this today. I think I've spent too long sort of talking about these things, which I think was really worthwhile because they are sort of laboured points. But in saying that, we're going to push on and get through as much as we can. Okay, so up until now, we've just been building everything into one big long script. But of course, this becomes really big and long and laborious, and it's really hard to sort of scroll up and down and find what you want. So what we can do is we can actually move some of this into other files, which are sort of in relative paths to our main Nextflow script. So in the content here, we've got the example that Evan covered yesterday. So we can include the processes that were described in the script normally, and we can put them in a different file called modules, or we can name it anything else we want, and then we can just include them, which is a really nice way of doing it. So I think we're just going to focus on the hello.nf example today, just because it's a little bit easier to kind of cover quickly. But what we're going to do is we're going to take these two processes. So now everything that is happening in this hello.nf script, again, you should have this in your sort of file directory off to the side here. We are going to create a new file. We're going to call it modules.nf. I'm probably just one of the few people in the world that still use Nano. Yes. So now we can just check out what's in that modules.nf. And we can see in here that all we've got is just this process, and for split letters and convert to upper. So we've moved it out of this script. Now we have it in this other modules.nf, which is local relative to this. So hello.nf, we've got our modules.nf sitting just there. And what we're going to do, it's quite nice to do this right at the top of it, so you can sort of like list these at the top of your script. You know exactly what's going on there. Just for time, I'm going to just copy this. So we've got include split.letters from modules. We've got include dot convert to upper from modules. So when we run this, Nextflow run hello.nf, being the name of the script again. And it's brought those in. So we have specified the module, the process. We've given each process a separate name, and we've included it in this modules file. So this is probably one way of doing it, a simple way of doing it. Just close these because we don't need them anymore. But here they are sitting in this file. In our example here, we've actually included them as separate lines. You don't always need to do that if they're in the same file. You can just list them like this. So they're going to be both included because they're sitting in the same file anyway. You can include them like this. And that should run again without any problems. Oh, why isn't that working? What have I done? Yeah, so it's used the wrong punctuation there. That's my fault. So again, all I've done is just sort of list those there under the same include statement. I did actually get a pretty good clue that it's in line 3 in column 9. I wasn't paying attention. Again, this has been included really nicely. What you'll find is that you might even specify this in separate files, and this is something that's really common in NF Core, for example, where you would say include, fastqc from, modules / fastqcs.nf or main.nf or something like that. So you can do that. This is kind of a slightly more advanced application of this as well. So you can only use a named module once in a workflow process. And this is just because the way the channels are driven through, if you have the same module used twice, the same process, and it's named the same thing, then it just gets a little bit confused, I guess. That the channel will be kind of partially full or it's been used twice already, and it just doesn't like that. Or Nextflow will it'll basically throw an error. So what you can do is include the process as something else. So you can basically give it an alias, which is really cool. This is super quick and easy to set up, obviously. So instead of just including split letters and using it as split letters like we did in the previous script, you give it an alias, and you can use them separately here in the same workflow script. So as an example, Nextflow run hello, and if we just pay attention to what comes up here. Yeah, so you can see here that it's called a split letters 1, split letters 2. We've used the same process using the different aliases twice. So that's just something that is quite useful to know. Output definitions. What do we have here? Okay, so quite often we have an output. You might not want to necessarily use set or use the equals to create a new channel every time. You might just think, oh, I'm only using this on the fly, I'm only using it once, I don't want to create a whole new channel. It seems like a lot of extra work. Well, personally, when I code, I still would, because I like to sort of see things all separated out in space. You might not. So the first example here is when you probably do something similar to what I would, and that you kind of create a separate channel for each. It's not going to work because I need to grab in the rest of the hello.script. So need to scroll back to, roll back to here. Oh, no. So sort of rolling back to here, we've still got this workflow script, but we also still need to go back in and add in these includes again. Include. So again, this is going back to kind of like a simplified version. So I've brought these in separately again, and I'm not using aliases. Just make sure this works. Cool. So this is just kind of like resetting it back to kind of the script a little bit closer to the start. But what we can do is we can kind of use this .out. So .out is works the same way as like an operator, in that instead of setting this as a channel like we did, let's put it directly below so you can do a direct comparison. Instead of sort of setting letters.channel, which we then use here as the convert to upper, we're just taking the split letters.out, which is taking the split letters output, being this here, and basically piping it straight into the convert to uppers process. Here we're doing the same thing, but we're just indexing it, saying 0 being the 0 element or the first element, depending on how you think of it. But basically what I'm trying to show here is that you don't always have to create a new channel. Obviously there's a channel here, this is getting fed in, but you can just use the .out to grab that code. So these two blocks of code are equivalent. And what we should be able to show is this. So yeah, exactly the same. Obviously these hashes change a little bit because I've changed the code, but the outputs are the same. Again, this here is just an example of where we can add this .upper, which of course is another operator, which will just change everything to uppercase, which is in this example here, but we're just going to skim over that for now. Using piped outputs, this is another way that you might want to design your sort of like main workflow, and that you can just pipe one into the other. This is probably easy when you've got like a really simple script with like singular inputs and outputs. For me, I find it more complicated because I can't sort of see things broken up, and especially if I am doing something that's sort of more complicated, moving parts around, it can be a little bit more complicated. Here is kind of like an extension of what we've sort of been talking about, in that up until now we've just been including these processes as from this modules file. We're including them here like this, but also you can actually include a workflow from somewhere else. So in this example, you might sort of specify your workflow in a different folder. Here it's going to be, the qualifier is going to be workflow, but in reality, this could be like a sub workflow, where you could specify like a series of steps and processes, which has been designed sort of separately or independently, and you could bring it in as like a large code block. Here it's just like the one code block already, but effectively what you can do is just specify, name a workflow, include it. Oh, block 12, what's that? Okay, I'm not sure that's failing like that. Okay, we might just keep moving on. It seems to be working now. But basically you can, it's quite common to specify like a sub workflow where it's a big block of text where you might just be doing like the quality control or like the mapping or something else like that, and bring it as a whole workflow. just to kind of create this this way of almost like modular parts of script rather than just single sort of tools. Yes, so the next sort of concept that we'll touch on is just this idea of take. So take works in a similar way to input, where we kind of give like an arbitrary name to what is being sort of received into this workflow. Here, for example, we are just going to take params.greeting. So in this case, I guess arbitrary is actually the right word. You're taking something into the pipeline, and then you can just specify that in the text like this. So this is kind of just like using it as a named option. So like, if you didn't have to take, you could do something like this, and then you could get rid of this. But for now, I guess the main thing to realize is that you can use take to bring in different parameters or files or channels or other things like that. And this is kind of what's showing here, is that my pipeline channel of params greeting is the equivalent of this. Cool. So the other thing that can be done is this is called calling named workflows, in which you can actually specify, you might include a series of different pipelines or steps or workflows, and based on different flags or criteria, you could say I want to use a different entry point. So here, for example, if we were to use this script here, this is probably something a little bit more advanced, but it's worthwhile knowing about the functionality. We've got these different workflows, my pipeline 1, my pipeline 2, and they're both sort of included there as part of the workflow script, or this main workflow script, or this part of the workflow script. And we use this thing called entry to basically say jump in I'll call this the wrong thing. You can use it to jump in at a slightly different point. I don't think I've set this up properly, so it's probably going to fail because I skipped a few steps there. Yeah, not paying attention. Yeah, okay. So here it's just jumped in at the entry point, but you can always like change this and jump in at 2, for example. So this might be a situation where you think, okay, like I've already done the QC separately, and I'm not worried about doing that for this pipeline. So I just want to jump in straight at my adapter trimming or something like that. So we can also really fine tune what's happening in each of these processes using different parameters. So we have this scope for parameters. I'm just trying to think of the right example to sort of cover this. Here's just a basic example. We were basically saying, say hello from modules. Okay, we might skip this for now just for time, but what's worthwhile knowing is that you can add parameters for particular steps. So this is really common in NF Core and other things like that, and this will be touched on tomorrow, but you can include specific parameters for different processes, and you can really sort of tune these as you need to. So you could add different like flag parameters or sort of filters or thresholds or anything like that. Little note here about DSL2 migration. That's just, there is some documentations and tutorials and stuff that's still floating around, which is DSL1. Just be aware of that. Sometimes you might find something and think, why isn't this working? And it is because it's DSL1 and something hasn't been updated properly. Comments, we talked about this already, so you can use this double dash to sort of include commented out lines. You can also use this multi-line option here. When you are defining things as a part of your configuration, this is more of a syntax thing. I just find what works for you, but effectively these two things here, use a good script. Just do it down here for now. But alpha.x could be the same as alpha.x. So you could write that in two different ways. That could become y, which is your string value, which is the same. So like those two are equivalent to when you're writing your configuration, such as what we've got here. Here we've used process.container, but we could also sort of write it like this, and then we have process curly brackets with container and Docker enabled and things like that, or process.container and then Docker curly brackets run options and enabled. So it's just a different way of writing it. Different people have different preferences. It's not a big deal. So here example, just more examples. We've sort of set different parameters, params.foo, params.bar. We've sort of set those in the config file. What is basically the point of this little bit here is just so that you can sort of overwrite them in different ways, and there is a hierarchy which is in the documentation. One of the helpers might be able to put that in the into the chat if anyone's interested. Again, like we've got a lot about here about the configuration environment. This is kind of what I was sort of talking about earlier, is that you can sort of add in different parameters to tune your processes. So like some of this looks quite familiar to what you've seen in directives, but you can also include it as a process. Here, there are some sort of specifications if you're trying to sort of set the amount of memory or CPUs or something like that. Just as you're, really sort of optimizing your pipeline. Some information there about processes and sort of including this stuff is kind of mapped lists. A little bit about singularity, a little bit about conda. So I've really just skimmed over this, which is a bit of a shame. I would have liked to spend more time on it just because we only got 15 minutes left today. The main thing I sort of just wanted to go back before I leave it is that the configuration file is a really powerful way of creating a set of parameters, just you can really put a lot of information in there that is important to your pipeline. It's a very quick way to sort of set up a lot of what might be sort of institutional specific, or if you're using a different using Singularity over Docker or Conda or whatever you're using, you can control a lot of this in the configuration file. So I would encourage you to go back and just have a wee look at that when you get a minute. Although we will sort of touch on some of it here under deployment scenarios. So with 15 minutes left, this is probably like 45 minutes of content. So I'm going to skim over it quite quickly, but hopefully there'll be enough in there that you'll sort of understand what is here and have the opportunity to come back later and have a look at some of it. So going back to what Evan talked about in his presentation yesterday, we can use different HPC or cloud cluster deployments. So Nextflow is really, really fantastic at bringing in scheduling jobs and sending it out to like a local ES or a back scheduler. And quite often what we'll see or find or have questions about is that people will sort of say, like, how do I do this with Slurm or SunGrid Engine or Amazon or whatever? And quite often what the biggest problem is that people are trying to do all of this themselves, and the Nextflow is actually quite capable of doing it without having to sort of create those fine-tuned, execution situations that you might normally have to do, submitting a job to a cluster, for example. But before we sort of get into that too much, you can, sorry, trying to think of this way to describe this. So Nextflow has, all the major HPC executors. You can just specify it using this process.executor in a configuration or profile or something like that. Not only that, you can specify, how it will interact with the queue system, how many CPUs, what type of memory is available you want it to use, how much time you're going to allow it, as well as the disk storage required for each task execution. And you can very quickly specify this as a process and include it in your configuration file, which is something that we just skimmed over. So you could just take all of this and put it into your Nextflow fig, for example. So instead of having it like this, you could probably get rid of most of that, or even include it here, just, container equals Nextflow, blah, 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 just like that. So very quickly, all of this is going to be automatically integrated into your execution and you can run it. But beyond that, you can really fine tune what's happening with each process. So in a situation where you might think, okay, this is a relatively quick process. I'm just, running FastQC. I only want 20 gigabytes of memory and we're going to put it on the short queue because I don't need to send it to the long queue or the high memory queue, or depending on what type of, HPC or other system you're using to sort of submit these jobs. So as an example, you can say with name foo. So any process with the name foo, you can specify these parameters. And then for bar, you say, okay, this is actually mapping. It's going to take a long time. I want to use 4 CPUs and 32 gigabytes of memory. So you can control this. And it's a really fantastic way of allocating resources to make sure that your pipeline is running optimally, especially if you are going to be using like a cloud computing resource where like cost is a factor. And if you're spinning up virtual machines, you don't want to ask for more resources than you need. This stuff's really, really important. So here's just an example of an exercise that you might sort of say with the quantification process. This would probably be in capitals if we were comparing it directly back to the process here, which also has the quantification but in capitals. But you're just allocating 2 CPUs and 5 gigabytes of memory. And in reality, I think we could probably run this because it's nothing too extraordinary. Nextflow run script7.nf. And what it's doing here is it's just saying, give me 5 gigabytes of memory, run 2 CPUs. It's because I called it the wrong thing, so I mentioned before. Education. It's going to run anyway. This is just telling me an error that it didn't know what this was, or there wasn't anything matching this, and I've probably misnamed it. But yeah, so let's just run this with what I've specified as for that process, which is really, really cool. You can also sort of create labels. So again, here, this is a process, which is called task 1. Convention might have had this in capitals, but we've labeled it as long. So in a configuration file, we can also use this process operator, I guess, called operator's probably the right word, but with label short or with label long. So because we've labeled this with long, it is going to apply the CPU 8 memory 32 queue omega being a different queue. You might be submitting it to one of the Sloan cluster. So again, very simply, we can create these really dynamic and interesting and really powerful, I think powerful is probably a better word for it, ways of tuning what we want to happen with the process and applying it potentially on scale. So, if you have a whole pipeline, you've got like 40 different processes and you think, okay, I'm either going to create short, medium, or long, or single, or anything else like that, you can add these labels and just apply it systematically to each of those so that you wouldn't have to go through and manually change this for each process, like you'd basically have to do up here with name. You can use this thing called labels, and it will just apply systematically across all of your data. So again, I think this makes it even and more powerful. So this is kind of like another, another step on top of this. Again, you can sort of bury this in a profile file, which is very similar to configuration profile. And you can just sort of say profiles. I want to have standard, cluster, or cloud. So profiles are probably best think of it might be like an institutional profile, and you might sort of generate this to sort of say do this on local, cluster, or cloud, and then you can sort of add specific parameters that are important for that local execution. So for example, if you have a genome file and it's going to be it's in this location for a standard or local execution. But then if you have a cluster and you think, okay, like if I use it on the cluster, it's going to be in a slightly different location. You can sort of add these processes in, like Sun-Green Engine. This could have been Slam, some information about queue and memory, and process conda. So I guess what I'm trying to say is profiles are a way of setting up different profiles that you can execute using this profile flag, which we haven't really talked about yet, but basically it works very, very similar to config. You can just create a profile. You can say I want to use profile standard, and it will know to use these parameters and processes for executing your pipeline. So here's just an example of that. Nextflow run script 7 profile cluster, so it's send it up to the cluster. So cloud deployment isn't something that I think we will go into. It's 11.4. But this might be important. So just for time, because I think we've only got 5 minutes left, I'm not going to talk about cloud computing, but I can assure you that there are like the major integrations for the major cloud platforms, AWS, Microsoft, there's a handful of others. And you can use Nextflow to kind of like automate a lot of this pushing it to the cloud and integrate like other storage systems, S3 Bucket, for example. All really powerful, and Nextflow definitely makes it a lot easier. But what I just wanted to sort of touch on, which I think is particularly cool, is this idea that you can also sort of say, I want to, execute this part locally, but then this part's a really, time-consuming and long process. I don't have the capabilities locally, and you can push that up to the cloud using these processes and parameters, sort of these queues. So most of that is just sort of covered here under like process selectors and AWS batch. There's a bit of a launch template there if you want to have any information about that. So scrolling back through, but yeah, I guess like the bottom line is that cloud deployment is also very, very powerful. Many of the things I've just talked about with sort of fine tuning your deployments also apply to the cloud. So you can sort of set up all of these things like that. And I do think it's really important, especially if you are using cloud platform, because if you get this too far wrong, anyone that's done cloud computing before will realize it can get quite costly quite quickly, just for asking for the wrong resources for a job. Okay, so I guess with about 4 minutes left, I don't really want to sort of start anything else. Tomorrow, what will be happening is you're going to have Phil and Harshal and Evan talk a little bit about Nextflow and NF Core and some of the sort of newer content and ideas that are happening within those communities. So what will be covered is just making sure that everyone knows how Slack, even though I think most of you are experts in using Slack already, using GitHub with NF Core, creating pipelines, some of the things that are happening with modules and the Nextflow schema, as well as Evan will talk a little bit about Tower as a product from Sakura, and how Tower can really simplify once you've got your pipeline, Tower can really simplify the execution of those, both locally and on the cloud. So with that, I think we will wind up for today. If there are any questions, please continue to drop those into the Slack channel. James and I and a few others will sort of continue to monitor those. If there's anything that hasn't made sense or you want some more information about anything, please just reach out. I do want to stress that we do cover a lot of material really quickly as a part of this workshop. So if things don't make sense, I'm really like to explain that again, hopefully in a way that makes more sense, or point you to the right resources to hopefully help you understand if there's anything, like I said, that doesn't quite make sense. So with that, we'll wind up for today, but thank you again for attending, and we look forward to seeing you tomorrow.